Okay, so for those of you who are not familiar with HelioScope, I did check out the participant list and I did see some familiar names. So hello, everybody who knows me. For those of you who do not, HelioScope is basically a fast and easy way of laying out and modeling the production of solar arrays built from the ground up to support solar. It automates a lot of the workflow and layout tools and also exports to CAD if you need to do that. So it's a really great way of prospecting and getting a quick answer to a customer about what the layout is going to look like and how much it's going to produce and that sort of thing. So to get started, I've just logged into helioscope.com and I'm going to create a new project. One thing that I've done before this call is I've created a profile based on that design guide that we were showing in the previous slide. I basically set up a profile with all the default assumptions for this project. So you'll see that really quickly here. So let me just give this a name. We'll call this our tracker project and an address. So I type in this address, it takes me to the location. And then under profile, I'm going to select the profile that I pre-created here, which is PVB profile. And that's going to preload the tracker assumptions. So I'm going to create this new project. That's going to take me into my project page. And for just this demo, I'm just going to focus on creating designs. So I'm going to create a new design. And we can give this a name if we want to. So if we're going to step through different iterations, we might call this one tracker and then create another one that's the fixed tilt if we want to compare them, for example. But once you create the design, that'll take you into a Google Map interface. We can switch between different mapping providers if we want to, but for now I'm just going to use Google's image. And basically all I need to do here is define a field segment for the area where I want to define modules. So I'm going to click New to create a new module, or excuse me, new area. Click onto the sort of points of the roof that I want. And I'm holding Shift to give me 90-degree angles locked in. And then I just continue my shape all the way down here. And this gets over here. So I'm basically just continuing to click around the roof. This is pretty basic stuff. Anybody can do this. You don't need to be a sophisticated CAD user to use HelioScope. And so you can see once I finish my shape by double clicking, the modules lay out with the assumptions of this profile. So it has the module preloaded. This is fixed tilt racking. So this is, I'm just taking all of this from their design guide. So it has the tilt of 30 degrees, which is really just for representation in the model. And then row spacing of 4.36, and then module spacing of 1.14. So that's basically just preloaded for me. I can change these if I wanted to. But for now, the quick thing is to just right click on the midpoint of a line, set my azimuth. And this is just to get the layout. Obviously, the azimuth of these modules is going to change as this is a tracking array. So, you know, if you have a poor building orientation, you're not going to have to suffer through that with this tracker. So that's one advantage there. And I'm just going to right click here to align my modules to the left a little bit. And so you can see how quick and easy it is to lay out modules. This is also a 3D structure if we want it to be. So if I give this building a height, we can see this in 3D. So we can see how this is laying out, what these look like side by side. Now, what you would need to do, of course, is avoid obstructions. And since we have a lot to cover here, I'm just going to really quickly just say this area is off limits and just draw in keep outs for this area. You can define a setback from that object, but for now, I'm just going to create copies of it by holding the Alt key, clicking and creating copies. So I get as many copies as I need of similar shaped objects. Let's grab one over here, one over here. And then it looks like we have a little bit of a smaller group here. So I'm just defining the obstructions on this array pretty quickly. And one of the nice things with HelioScope is that you can do different versions. You can say, just to give this customer an answer, I'm going to do this quick version just to get an assessment of what is possible. And then if you get closer with that customer to closing, or maybe they sign a contract and you want to go a little bit deeper, you can draw each of these individually. You can model the 3D shapes if you really want to. But for our purposes, I think it's fine to just make this, looks kind of like a SIM card. Okay, so that's my layout. This is how the modules are fitting in here. I might make some minor adjustments. I might move this one up, for example. Might move this over. But otherwise, I think this looks pretty decent. And we can go from there. If there's individual modules that we want to remove, we can just right click to remove them. So if you're in keep out mode, you can just right click on modules to toggle them on and off. So maybe I'll do that for this one here. Okay, so that looks pretty good. So now once I'm satisfied with the layout of the array, I can move on to electrical. And again, I predefined the inverter and optimizer. So this is automatically laying out with a solar edge 33.3 based on a 1.35 DC to AC ratio. So I just define that in my profile. Of course, I can change the inverter count. We have the wire gauge, so we can see the voltage drop by wire gauge. So if we want to quickly optimize the conductor size, we can do that. We can view the single line diagram of how this is connected electrically and export this to CAD. And if we save and exit, we'll get a design summary. So we can see that this tracker layout, how many inverters are used, how many strings, and what's their total length, number of optimizers and number of modules, and then a picture of the array that we can show the building owner to give them an understanding of where the tracker is going to be laid out. And then if I want to take this layout into CAD, I can do that. I can click export and download a DXF of this layout and open it up in CAD. Of course, we also have the ability to integrate with Energy Toolbase and bring data into Energy Toolbase. And I'm basically done with my design at this point. So I'm finished with laying out the array. You can see that was pretty quick. And so now I'll hand this over to